Good morning, grade 10 students of Valenzuela. Welcome to a whole new week of learning science with me, Teacher Bea, and join me as we discover things about mountains, volcanoes, and earthquakes. But before we get into that, here are some of the objectives that you need to achieve after this lesson. So first, you should be able to locate the earthquake's epicenter using triangulation method. Next is to plot the active volcanoes, earthquake epicenters, and major mountain belts. Third one, you should be able to describe the distribution of active volcanoes, earthquake epicenters, and the major mountain belts. And lastly, infer the relationship of tectonic plates, earthquake epicenters, and active volcanoes. So some of you might be familiar with triangulation method because it is also being applied in various fields to analyze data and validate information coming from different kinds of resources. But do you know that triangulation method can also be used or be applied in association to earthquakes? And that is actually finding the location of the earthquake's epicenter. So how do we apply triangulation method in finding Earth's location or earthquake's location? And what do we mean by the earthquake epicenter? So last September 10 of this year, we had a nationwide earthquake simulation drill held online. So what is meant by earthquakes? Earthquakes is the shaking of the earth resulting from a sudden release of energy in Earth's atmosphere that creates seismic waves. So how does it actually happen? So this happens when two blocks of the earth split or slide past one another. So whenever you hear news regarding the earthquakes, what are the important details that we usually hear? So some of the significant details we use or reporters used to be reported are the intensity. This is the strength or the shaking produced by the earthquake in certain locations, which is determined by the effects or damages caused by the earthquake. Next is the magnitude. Now, the magnitude measures the energy released at the source of the earthquake. And also, one of the most important details for earthquake is the location of the earthquake epicenter. So what exactly is an earthquake epicenter? So in this illustration, you see the fault line or the fault plane that we call. So the location below the Earth's surface where the earthquake actually originates is what we call the hypocenter, or also known as the focus. And the direction just right above the focus is what we call the epicenter. So from the word epi, from the word epi means above, so epicenter is located above the Earth's surface. Now, let's go ahead and find the location of the earthquake's epicenter using the triangulation method. So basically, triangle has three sides, right? So we need three seismic stations or recording stations in order to find the earthquake's location or the epicenter as we call it. So in this particular example, our three recording stations are Batangas, Palawan, and Cagayan de Oro. Now, the very first thing that we need to do is to find the time difference between the arrival time of primary waves or the P waves and the secondary waves or the S waves. So we are going to find their difference among the three or for all of the three seismic stations. But in this case, I have already given you the data for that. So for Batangas, the time difference is 26 seconds. For Palawan, that is 50 seconds. And for Cagayan de Oro, that is 34 seconds. All right, so for our next step, we are going to determine the distance from the epicenter to the seismic location. And we calculate that through this particular equation. So distance is equal to time difference over 8 seconds, and that is constant, times 100 kilometers. So let's have Batangas first. So that will be distance is equal to 24 seconds or 26 seconds over 8 seconds times 100. So what is it going to be? Oh, okay, I actually see an answer in the comment section. All right, thank you for answering. That is 325 kilometers. Okay, now for the next station, for Palawan, so the distance is equal to 50 seconds over 8 seconds times 100 kilometers. So what will be our distance? All right, good job. That will give us 625 kilometers. All right, for the last one, which is Cagayan de Oro. So the distance is equal to 34 seconds over 8 seconds times 100 kilometers. And that will give us a value of, 425 kilometers. Okay. Now, next step is to convert the distance in centimeters with respect to the map, because this is where we are going to plot our triangulation. So the conversion for this one would be 1 centimeter is to 100 kilometers. All right. So for Batangas, the distance is equal to 325 kilometers times 1 centimeter over 100 kilometers. So that is just simply 325 kilometers divided by 100 kilometers, and then we cancel the km unit. And we get, all right, that is 3.25 centimeters. Now, for Palawan, let's have distance is equal to 625 kilometers times 1 centimeter over 100 kilometers. And that's going to be, all right, 6.25 centimeters. And lastly, let's have Cagayan de Oro. So let's plug in distance is equal to 425 kilometers times 1 centimeter over 100 kilometers. And our computed value there will be, all right, 4.25 centimeters. So there. Now you've got all the data needed for us to proceed with the next step. So let us now plot this data on the map and do the triangulation. Okay. So for this step, you are going to need pencil, ruler, and compass. So first thing that you need to do here is to measure your converted distance on the map and make a circle around it. So since we have 3 seismic stations, so you are going to measure and draw the circle for the 3 seismic locations. Okay, so once we do that, after drawing the 3 circles, observe where these circles intersect. Where do you think the epicenter is? And there, finally, this intersection is the location of the epicenter, which is, in this case, at around Masbate. All right, that was just a really cool and fun method, right? So now, moving forward, Okay, so you see I have here a map. So on the down below you can see the legend. So the yellow pattern pertains to the volcanoes and the red ones pertain to the distribution of the earthquakes. So I'll be giving you at least 30 seconds to observe the map, and then I'll be asking you a question later on. All right, so time's up. So my question is, where are volcanoes and earthquakes usually located? So there, based on the map, earthquakes and volcanoes are actually located at the edges of the plate boundaries. And also, if you could observe, they are not randomly distributed. Instead, as you can observe there, the location of the volcanoes is also the location of the earthquake epicenters. So let's have the next one. So now, please do observe the location and distribution of the mountain ranges. Okay, so where are mountain ranges usually located? All right, so just like the volcanoes and earthquake epicenters, mountain ranges are also formed at the edges of the plate boundaries. All right, so now that you know that mountains, volcanoes, and earthquake epicenters all lie at the edges of the plate boundaries, what can we conclude from there? So it must be telling us something about the plate tectonics, right? And how it works. So you see, if mountains, volcanoes, and earthquakes are all distributed at a certain pattern at the plate boundaries, and mountains are continuously growing, and there is a continuous activity for the volcanoes. They are active and regularly erupting, and there are occurrences of earthquakes, then it could only show that there is actually some processes and mechanisms or various activities that are actually happening beneath the earth, or that are actually happening at the edges of the plate boundaries. Because technically, nothing will be formed if nothing is going on, right? Okay, so another thing that is common about the distribution is that they actually lie at the Pacific Ring of Fire. So I know you guys are already much familiar with the Pacific Ring of Fire. So I want you now to cite 5 countries that belong to the Pacific Ring of Fire. So I'm going to give you an ample time to think and write your answers on the comment section. All right, time's up. So let us now see if we got your answers on the list. So I actually have listed here 18 countries that are located at the Pacific Ring of Fire. So we do expect that these countries which are located at the Pacific Ring of Fire usually experience a lot of volcanic activities, prone to earthquakes, and have extending mountain belts. All right? So we have here Philippines, Japan, Chile, Mexico, United States, Russia, Indonesia, Taiwan, Peru, Guatemala, Canada, Malaysia, Australia, Ecuador, Colombia, New Zealand, Singapore, and Panama. All right, good job, learners. So now you now have the privilege to ask me a few questions, and some other questions will be entertained on your follow-up discussions with your respective subject teachers. Okay, so let me just get my phone. All right, so I will be choosing questions from the comment box. Okay, I got the first question. So, ma'am, is it possible for the earthquakes and volcanoes to occur away from the plate boundaries? Oh, that is actually an interesting question. Well, yes, it is actually really possible for the volcanoes and earthquakes to form away from the plate boundaries or within the plate boundaries, because that is actually another type of tectonic setting. And we call that intraplate earthquakes or intraplate volcanism. So it is being formed, or volcanoes and earthquakes are occurring on the plate boundaries away from, on the plate away from the boundaries. Okay? So let me find another one. So our second question will be, okay, here, how do volcanoes form? Okay, so there are actually different kinds of processes or mechanisms that are happening at the different types of plate boundaries. So yes, we have different types of plate boundaries. And these processes could actually lead to the formation of different types of geological features, and that includes, of course, the formation of the volcanoes. So don't worry, your question will be actually discussed on our next topics. Okay, so now for the third question. So this is going to be our last one. Okay, let me find the third one. Okay, this is a good question. So it says, ma'am, you mentioned earlier that volcanic activities happen at the Pacific Ring of Fire. Why is that so? Oh, all right. Actually, Ring of Fire is the site of volcanoes around the Pacific Ocean, which results from the subduction of denser oceanic crust beneath lighter continental crust. So what do I mean by that? So meaning, I mean by the subduction is that the denser oceanic crust is actually moving below the lighter continental crust, thus forming volcanoes, causing it to erupt regularly. And so, Pacific Ring of Fire is actually the bed for the most active volcanoes all over the world, because this is the location of most of the Earth's subduction zones. So there, I hope I answered your question. Anyway, this will be all deepened as we discuss more about the tectonics on the succeeding days. Okay, so now these are your module activities you ought to answer for this week. Okay, so on your first day activity, on page 10, you are going to locate the epicenter of the earthquake using triangulation method. Next, on the second day, you'll be plotting the locations of volcanoes and earthquakes on the world map, and that is on page 11. Now, on page 13, which is on your third day, you're going to analyze the distribution of volcanoes and earthquakes. And lastly, on page 14, you are going to describe the relationship of volcanoes, earthquakes, and major mountain belts with respect to the tectonic plates. So that's it for this week. I hope you guys learned something that could really help you in answering your modules. So see you guys next week and keep safe.